Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to jump into chapter number 6. Now, chapter number 5 only had 4 lessons. It was very short. Chapter number 6 is not so much. I think there's 14, something like that. So this one's going to be an exciting chapter right here. Lots of stuff to learn in this chapter. But the first few lessons, are lessons that you already really know. We're just going to do some review. We'll skip over those pretty quickly, and then we'll get into some new stuff here about lesson 4 or 5, something like that. So I want to start off with, if you will, open up your books to page 176. Page 176 is where this chapter starts. You'll see a quotation, and I put it up here on the screen. I want you to look at it. It's by a German philosopher, mathematician. This guy is responsible for developing calculus, one of the most complicated applications of mathematics that there is, and it really opened up the door for computer science. And if you want to know who the great grandfather of computers are, it's this guy right here. He came up with binary code, some different things like that, and this guy lived a whole hundreds of years before computers were ever made. So he said, as God calculates, so the world is made. In other words, when he looked at mathematics, what he saw was God's handiwork in creation. He saw numbers everywhere he looked. He saw a God of order. He saw a God of perfection. He saw a God that just the way that God calculates things, very exact, very precise, that's the way the world was made. And one thing is, a lot of times these philosophers, these mathematicians, they were Christians or they believed in God. The world tries to teach you that that's not true, that these guys didn't really believe in God, and that they were, now there's some of them that didn't believe in God, but a lot of the mathematicians, a lot of the scientists in years gone by, they were Christians and they believed in God. And Leibniz was one of those that definitely believed in God, and he continued to try to prove that God did exist, and he used mathematics to do that. So, interesting. Go ahead and you can look down there at the lesson. We're going to be starting on 6.1, adding polynomials. What does it mean to add polynomials? Well, probably the first thing we need to do is to define what is a polynomial, right? So let's go ahead and start there. If you look down here at the screen, I've got several different things written here, and I think you know this for the most part. You've heard me say these before, but let's go ahead and just look over them. First one is monomial. Monomial. The root word there is mono. Mono means one. And so monomial, that means it has one term, just x squared. Maybe it's just a number, maybe it's just a 3. That's 3's a monomial, one term. X is a monomial, y is a monomial, x to the 5th power is a monomial. So there's lots of different possibilities here. This is just one example. A binomial has 2, okay? X squared plus 1. Okay, x minus 6, x plus y, it just has 2 pieces. Notice that this right here, this plus sign, is what is separating the terms of the binomial. Trinomial, you have 3. So in other words, there's one, x squared, there's another one, x, and there's another one, the 1. Look at these. These plus and minus signs divide or separate the terms. So we have a trinomial. There's 3 of them there. And then the last one down there at the bottom is the polynomial. This is the one that we're going to be talking about in chapter number 6. Now, we've kind of already dealt a lot with the binomials and the monomials and the trinomials, right? I said this is going to kind of be a little bit of a review right here. So now what we're going to do is we're going to launch into the polynomial. The polynomial, in other words, now technically a polynomial has 2 or more. But the polynomials that we're talking about, we're going to be dealing mostly with 4 or more. Now, it could have 2. A binomial technically is a polynomial. A trinomial technically is a polynomial. So we may be dealing with a little bit of that in this chapter, but for the most part, we're going to be dealing with ones here that have more than 3. 4, 5, 6, 7, 10, however many. Okay? All right. One thing that we need to talk about before we really get into this is how do I expect you to write your answers? What is the right way to write a polynomial? In polynomial order, we want to start alphabetically. So we want to put A first, then B, then C. We want to put X first, then Y, then Z. Okay, A, B, C, X, Y, Z, and whatever's in between there. Okay, in order alphabetically. That's the first step. The second step is that we would write descending degree. Okay, what does that mean? Descending degree. Degree is the exponent. So we want to write the exponents in descending order. What does it mean to descend, to go down? So, for example, descending order would be x cubed plus x squared plus x plus 1. We're descending, we're going down. So that's descending order. Up here, alphabetical would be x plus y plus z. Okay? So, and we have to put them in that order. So we first of all have to do alphabetical. So we're going to put all the x's first. Then we're going to put all the y's next. And then we're going to put all the z's. Well, how do we arrange the x's? Well, descending. So we'd have x squared, x, okay, and then go that way. Let's do one. Let's arrange this thing. So here's an example. We have just randomness all along here. And what we want to do is we want to put them in order. So we're going to take all the x's first. So there's an x, and there's an x. Now, so those are our 3 x's that we have. But we want to write our x's in what's called descending order. And descending degree, so the exponent. So we want to start with the biggest and go to the smallest. So the biggest exponent that we have is that x cubed. So we would write x cubed first, okay? And I'll mark them off once I've written it, okay? Then we go to the next one. There's an 2x squared. And notice it's a positive 2x squared. These signs technically go with the term that they're with. So positive 2x squared, all right? So we'll mark that guy off. And then the next x, or the last x there, is just x. So that's a positive x. And then we would go to the y's. And so let's see, there's a y and there's a y. We'd go with the biggest one, the biggest exponent. So we'd have plus 4y squared. Okay, done with that guy. And then we have a 3y. Okay, and then the only thing that we have left is this nothing, this constant term. It doesn't have a variable, so they always go last. So if it is a constant, it goes at the end. And there we go. We've written it now in correct order. And so we have x cubed plus 2x squared plus x plus 4y squared plus 3y plus 7. And this is the way that I want you to write your answers for me in that order, okay? Starting with the alphabet, so starting with A, B, C, X, Y, Z, and then going to descending order of the exponents. Descending order of the exponents. All righty. Why do I tell you that? Because now we're going to get into when we're actually going to start using that. And again, this is somewhat review for you. And this is on chapter number 6, lesson 1. This is on page 176 still. Actually 177. I've kind of turned the page there. It's at the bottom of the page of 177. There's an example. So there's the example, and what we want to do is we want to go ahead and solve this. Well, one thing that we can do is we can eliminate the parentheses. Okay, this is the associative principle. In other words, we can associate all this stuff together. We can get rid of the parentheses. Now, one reason why I can get rid of these parentheses specifically is because it's a plus sign. really what we're doing. Let me show you what we're doing. We're actually distributing this positive to this. But remember, everything has a 1 in front of it. What is the identity property in algebra? Well, the identity property is the number 1. Positive 1 is identity when you're multiplying. So when we distribute positive 1 to that, no change. When we distribute positive 1 to negative 4x, no change. When we distribute positive 1 to negative 5, no change. The positive 1 does not change anything. So in other words, what we can do, since nothing changes, is just eliminate the parenthesis. It doesn't need to be there. Okay? Now that's going to be different here in just a minute. I'm going to show you subtraction. When you have the negative sign, the negative 1 does change things. Okay? And so we have to address that. But for these ones, the adding, the positive sign, the positive 1 does not change anything, so we leave it the same. All right. So now what do we want to do? Well, this is what I like to do. I like to kind of find a little pattern, a little code, and I like to identify like terms. Okay? So the things that are the same. 5x cubed plus x cubed. Those are the only x cubes there. I always start with the biggest one. I start with the x's, then go to the y's, then go to the z's. I start with the a's, then go to the b's, then go to the c's. So I go alphabetically, and then I go descending order. So again, I'm following these rules that we talked about up here. So alphabetical order and then descending degree. So I want to follow those rules. So we started with the first letter, it's the only letter, and then we started with the biggest exponent, which was the 3. All right, so I put a box around those two. What do I want to do with those? I want to combine them. I want to add them. Okay, so 5x cubed plus x cubed. Don't forget that this technically has a 1 in front of it. So we have 5x cubed plus 1x cubed. Well, the way that you add is you only add the coefficients. You don't touch the x cubes. Those stay the same. So you end up here with 6x cubed. 6x cubed. And then I would come, let me circle the next grouping, the 8x squared and there's no other x squareds. Okay, so I just bring down the 8x squared. There's nothing to add it to. Let's 8x squared. Let me underline the next grouping. So the x's, negative 3x and negative 4x. Again, I'm combining those. Negative 3x plus negative 4x equals negative 7x. I have students all the time right here. They ask me, Mr. Steve, does that mean subtract? And what I tell them is, yes. And then I'll have students that say, Mr. Steve, is that a negative sign? And I'll say, yes. It doesn't matter what it is, okay? You do the same thing with it. So if you have, let's say you want to do this, negative 3x minus 4x. Well, how do you subtract in algebra? You change the sign of the second, okay, and add. Okay, so we're back to this. What you're doing is you're combining, you're adding. So you're going to add these two together. So you're going to get negative 7x. Negative 7x, because you had 3 negative, and then you added 4 negative, and so now you have 7 negative. You owe somebody 7 x's, whatever x is. All right. And then the last one, I will go ahead and use a, let's see, I'll use a triangle for these guys, okay? So I got my little code. I use different types of shapes. You can use different colors, whatever you want to do there. You don't even have to do it. And another thing I do actually like to do is I like to cross these off as I go. I wasn't doing that, but I'll do it now. All right, so what's left is a positive 1 and a negative 5. Well, when you add those together, you would get a negative 4. So if I have positive 1 and I add negative 5, I have negative 4. So there's my answer. 6x cubed plus 8x squared minus 7x minus 4. All we're doing is combining like terms. That's it. In your book, they tell you to do it to stack it up vertically. Don't do that, okay? I don't know why they teach you that. I don't like it. I don't like it at all. All right. It's just too confusing. Nobody does that. Nobody does that in algebra. Okay. So stop doing that. That's like baby math stuff where you stack things up vertically. We're just doing horizontal. I want you to learn horizontal. So don't even do what they show you in the book as far as stacking them up vertically. It's just going to confuse you. All right. So here we go. Let's do the next one. This is on page number, let's see, 178, page 178. And so let's do this one. Here's what we're going to do. I'm going to do this one quite a bit quicker. What we have to do here is we actually have to distribute first. We can't do anything until we distribute that. So we're going to get 5x squared plus 10x minus 5. And then we're going to distribute this. Plus 3x squared plus 3. And now we're going to go through it and we're going to locate all the same things. So there's a same term. And so we're going to have an 8x squared. Here's an x squared. There's no other x squared, x's. And so we would then have these and I would get minus 2. So there's my answer. 8x squared plus 10x minus 2. All right. I'm going to keep going because this stuff is stuff that you should know how to do. This is kind of just review. So we're going to click right over to the next lesson, 6.2, and we're going to do this real quick. This is on page 180, page 180. Now we're going to subtract. The only thing that changes with subtraction is that we are going to distribute. We're just going to distribute. What are we going to distribute? Well, we're going to distribute that -1 right there. Okay, the negative sign or the -1. Because don't forget there's a -1 there. But the 1 doesn't really matter. We're going to distribute the negative sign. Okay, so everything up here stays the same because look, there's no negative sign in front of that one. That one just stays the same. So let's just take it out of the parentheses. So minus 5x squared minus 8x plus 3. Now we have to distribute. So distribute the negative sign through there. Negative times 2x squared gives us negative 2x squared. Negative times negative, that gives us positive 3x. Negative times negative, that gives us positive 12. Okay? That's so important. And so many of you are going to miss that. I promise you that. You're going to get it wrong, and then you're going to wonder why, and I'm going to say, did you distribute? And you're going to go, no, I didn't distribute. Okay? I can only tell you so many times. I can beg with you. I can plead with you. I can stand on my head if you want me to. But you have to do it. And some of you are like, can you really stand on your head? Yes, I can stand on my head. Okay? Trust me. You're going to have to trust me there. Maybe I'll do it for you someday, but I can stand on my head. And so now what do? Now we just combine our like terms. We go back to what we were doing before. So let's go to the x squareds. And don't forget to take the sign with it. That's very important right here too. Negative 5x squared and negative 2x squared. We're combining them, so we're adding those together. And that's going to give me 7x squared. Here's our x terms. There's a negative 8x and there's a positive 3x. So that's going to give me a negative 5x. And there's my plus 3 and there's my plus 12. And that's going to give me a positive 15. So, oh, I forgot my negative sign out here. I thought I had written it. There we go. So negative 7x squared minus 5x plus 15. That would be our answer. And so notice, we actually came out with a trinomial for an answer. We started with polynomials and we ended with started with 2 trinomials and our answer was 1 trinomial. All right. Next, this is the last one that I'll do, and I'll be done. So let's move through this. First thing we're going to do is we are going to distribute right there to all of them. So I'm going to have 8x squared minus 7x plus 1. Minus times minus gives me a positive 5x squared. Minus times minus gives me a positive 2x. Minus times plus gives me a minus 3. Then I would just go through it and I would find my like terms. So here's a like term right there. Remember, start with the biggest one, start alphabetically and start with the biggest one. So that's going to be a 13x squared. 13x squared. And these practice problems are in your book on page 180. You should be following along in your book so you can see what I'm doing and see that the answers are coming out the same as your book. And there is a 7x squared, or 7x, and there's a 2x. So negative and positive is going to give me a negative 5x. There's a plus 1, and there's a minus 3, so that's going to be a minus 2. 13x squared minus 5x minus 2 is the answer there. All right. So there we go. We got 2 of the 14 lessons done, and those were ones that hopefully you should be able to handle. Those are things that we're just kind of redoing, re-going over things that we've already been doing in the past, okay? If you have any questions, you can always comment there and ask me those questions. We'll see you later. Have a good one. Bye-bye.